everyone. We are starting topic 11 on circles. Today's notes are going to be on center, radius, and diameter. So a few vocabulary words to cover. And I'm just going to jump right into the notes. First of all, we have that a circle is a set of all points in a plane that are the same distance from a given point called the center. And you name a circle by its center. So this one right here is called circle P because of the P right here in the center of the circle. We then have two vocabulary words of diameter and radius. And these words should be familiar to you, but just to go over them again, it says that a diameter is a segment that passes through the center of a circle that has both endpoints on the circle. So they're showing you right here that the diameter goes from one side through the center to the other. That's pretty much a simpler way to define diameter. And then it also states that a radius is a segment that has one endpoint at the center and the other endpoint on the circle. So here, if I start at the center and move to one endpoint on the circle, that is a radius. Now there are really unlimited radii in a circle and unlimited diameters. We're used to seeing the diameter going straight across like this one is, but this could also be a diameter. This could also be a diameter. And your radii could be all over. So, moving on, it says that you also name a segment by its endpoints. And so we would read this line with AB with a line over it as segment AB. And so this diagram shows us segment AB, BC, and AC. It goes on to also say that to refer to the length of a segment, you write the letters without the segment bar on top of the letter. So AB is actually 3 inches and AC is 3 inches. That's just a little, just trying to be careful with our writing. Just to be careful here, we can't know for sure if BC is a diameter because they don't have the center of the circle label. And AB and AC are definitely not radius or radii because they're definitely not going through the center. So question number 1 is saying that an art class developed this logo to represent the school in an art show. Determine which segments are radii and which are diameters. I'm going to let you guys just go ahead and decide which ones are which, and some of them might not be used at all. All right, so for the radii is just kind of like cacti, cactus. Radii is just one radii. I said PB, PC, AP, and PD. If you look at this one right here as BD or P, let's see, where's the one that we didn't include? AD, here we go, sorry about that. AD is called a chord, technically. A chord is just some line that hits two of its endpoints on the circle, but doesn't necessarily go through the center, so that is called a chord. So a couple of those lines are not on there. The only diameter, the only one that has two endpoints on the circle and travels through the center would be AC. So question number 2 is asking how many radii are shown. Go ahead, count that up. And I said that there were 4. Remember, radii goes from one endpoint to the center, endpoint to the center, endpoint to the center, and endpoint to the center. All right, on to the back. This again is just kind of summarizing the relationship between the radii and the diameter. And it says that 2 radii of a circle that lie on the same line form a diameter. So the length of the diameter, D, is twice the length of the radius, R. So we could say that D, the diameter, equals 2R, 2 radii. You could also solve this one-step equation or rewrite this, transform this one-step equation where you divide 2 on both sides. So you would now say D divided by 2 also equals R. So we're going to keep referring back to those two relationships to help us answer the following questions. So example 3 says the distance from a car to the center of the Ferris wheel is 221 5/10 feet. Approximately, then, how tall is the Ferris wheel? So they're telling you from the distance from a car to the center of the wheel is approximately 221 feet. So how tall is that? Well, we're assuming that the cart is touching the ground. and then going to the center, that's also the same thing as a radii. But they want to know how tall the Ferris wheel is. So if this is one radii, here's another radii, we would say the relationship of d equals 2r would help us figure this out. If we know that one radii is 221 feet, I'm going to substitute that in place of my r. I go through and I multiply, and I'll get 443 feet. And again, it's approximately because I know that the carts, as they go around the Ferris wheel, they kind of move differently. So question number 4 says that in this diagram, ST, so this line right here, is 4 1/3. So what would be segment SO? Well, the ST is the diameter. So I need to take the diameter and divide it by 2 to calculate the radius. So we're going to take 4 1/3 and divide it by 2. So I'll need to rewrite 4 1/3 as 13/3. And I'll place 2 over 1. Then I'm going to rewrite this as a multiplication problem. The first fraction stays the same. Division becomes multiplication. The 2 first becomes its reciprocal of 1/2. I then multiply 13 times 1 to give me 13, 3 times 2 to give me 6, and that will leave me with my mixed number of 2 1/6 feet. And it makes sense that my answer needs to be less than 4 1/3 because radii is half of the diameter. Now for the next example, they're telling you, by looking at the shape here, that this orange slice has a radius, or radii, of 2 5/10 inches. They are telling you that the expression 3x minus 1 represents the diameter. They want to know then what would the value of x be. If we go back to our relationship equation, d equals 2r, I know that the d is 3x minus 1. I know that the radius is 2 1/2, so I can substitute that in there, and I can go through and calculate this out. So I'll have 3x minus 1 equals 2 times 2 5/10, which will be 5. I now just have a two-step equation, so I will add 1. I get 3x equals 6, divide by 3, and I will get an answer of x equals 2. Okay, go on and try number 6. All right, so I might have a little bit more work here than what you have, but I just started with the original equation again of d equals 2r, just because I'm reminding myself of the relationship between the diameter and the radius. I then went through, and as I looked at the diagram, they're telling me that km, right here, is 2x minus 4. So this whole thing is 2x minus 4, which is equivalent to 2 times lm, which they're telling me is 12. So I just wrote down too what segment km compared to what lm is. Lm needs to be multiplied by 2 to equal km. So I now have substituted 2x minus 4 equals 2 times 12. I go through, I simplify, 2 times 12 is 24. Then I add 4, divide by 2 to get x equals 14. So this is very similar to the previous topic where we were using equations to figure out other values of angles and so forth. Please remember, if you have any questions, please ask me tomorrow. Have a great night.